In this video, we're going to solve rational inequalities, and you'll notice that the process that we go through will be almost exactly the same as we did in the last video. This is the exact same slide I had in the last video. We're still following the exact same process. The only difference here is that our boundary points are going to be not only our solutions, but also where f of x is undefined. That's really the only difference, because we might have some undefined points because we have a rational, which means we have a denominator that includes a variable. So let's take a look. Again, thankfully, this guy is already factored for us, so I don't have to do any of the factoring. So what I'm going to do is I'm going to find my boundary points. And my boundary points would be where the numerator is equal to 0, so where x minus 1 equals 0 or x plus 3 equals 0, but also where my denominator is undefined, so where x minus 4 equals 0. So it's really kind of the same thing I did before. So my boundaries are 1, -3, and 4. So again, I'm going to make my table, and my table will be all of the parts of my domain. And again, if you need to draw it out and say this is negative infinity to positive infinity, this is -3, 1, 4. So this is negative infinity to -3, -3 to 1, 1 to 4, 4 to infinity. Feel free to do that. If you don't have to do that, just don't waste your time. So I'm going to start with negative infinity to -3, -3 to positive 1, always open brackets on these, 1 to 4, and 4 to infinity. So I always have one extra column so that I can put all of the rest of my stuff. And then I've got 3 factors, x minus 1, x plus 3, and x minus 4. And then remember, I always have, whoops, not sing, but sine. I've always got 2 extra rows because I got this guy up here at the top and the guy up here at the bottom. So now I'm just going to take values and plug them in. So this, let's choose, say, -5. Let's choose 0. Let's choose 2. Then let's choose 6. Again, any test point, as long as it's between the two values that I've given you, will work just fine. -5 minus 1, that's a negative. -5 plus 3, that's a negative. -5 minus 4, that's a negative. Negative times a negative divided by a negative gives me a negative. 2 negatives make a positive, 1 left over makes it negative again. Using the same for 0. 0 minus 1, that's a negative. 0 plus 3, that's a positive. 0 minus 4, that's a negative. Oops, just negative, just the sign. If I took a negative times a positive divided by a negative, I would end up with a positive. Now let's look at 2. 2 minus 1, that guy's positive. 2 plus 3, positive. 2 minus 4, negative. If I took a positive times a positive divided by a negative, I would end up with positive divided by negative, which is negative. And lastly, 6 minus 1, positive. 6 plus 3, positive. 6 minus 4, positive. Obviously, that gives me a positive. So my solution is, and this is going to get just a touch more complicated. My solution is where I'm looking for less than or equal to 0. So again, I'm going to look at negatives. And the only part that's a little bit more complicated in this question is when I'm looking at my solution, because it's or equal to, I can include 1 and I can include -3. But I cannot ever include 4, because 4 obviously makes the denominator 0, which is no good. So I can choose, and my answers, of course, are these two. I'm going to take negative infinity to negative 3. I can include negative 3 because it's in the numerator, and it's an or equal to. Union, then I'm taking 1 to 4, so 1 can be included, so closed bracket, because that's in the numerator, but I can never let x equal 4 exactly, so this is going to be to 4 and then an open parenthesis. Let's take a look at another question, and this one looks like it would be super straightforward and easy, but it's actually more difficult than our last one. Even though we have things that are already factored for us, which is nice. I've got my x minus 5 and I've got my x minus 7. Notice that I don't have 0 on the right side, which is what I want. So I'm going to subtract 3 from each side, and that's going to give me this. So that's one step closer because now I have a 0. But in order for this to work, I need for there to be just one fraction on the left. So what I'm going to do is I'm going to keep my x minus 5 and x minus 7, and I'm going to take 3 times x minus 7 over x minus 7. Now, why am I going to do that? Because on my next step then, I can write everything as a fraction over x minus 7. My numerator would be x minus 5, and then minus 3 times x, so minus 3x, and minus 3 times minus 7, which is positive 21. So if you wanted to show a step in between, you certainly could. I'm just trying to save space here. Now let's keep going. I'm going to combine like terms. So x and minus 3x is negative 2x. So I combine those two. Minus 5 and plus 21 plus 16. And then I'm going to go ahead and factor. So negative 2x minus 8 over x minus 7 is less than 0. So now let's find boundaries. I'm going to set x minus 8 equal to 0. So x is 8. I'm going to set x minus 7 equal to 0. So x is 7. Those are my boundary points. So again, as I'm setting up my table for my intervals, I'm using negative infinity to 7, 7 to 8, 8 to infinity. On the left-hand side, I'm going to use x minus 8 and x minus 7. And actually on this one, I'm going to put negative 2 times x minus 8 because that's what's going to end up happening. And then I'm going to use my sign. And then from here, I'm just going to fill it in as I go. So now let's go ahead and I didn't leave room for a test point, so here let's say I'm going to use 0. Here I'll use 7.5. Here I'll use 10. Remember, you can use any test point as long as it's not on the boundary. So I couldn't use 7 or 8 on any of these. So now let's take a look. If I plug in 0, get 0 minus 8, which is negative 8, which would be times a negative 2, which would be positive. 0 minus 7 would be negative. My sign is negative. Positive times a negative, or positive divided by a negative. 7.5. 7.5 minus 8 gives me a negative, but I'm multiplying that by a negative, which gives me a positive. And then 7.5 minus 7 is positive, which gives me a positive. And lastly, 10. So if I took 10 minus 8, that gives me 2 times a negative 2, that's a negative. 10 minus 7 would give me a positive. Negative divided by a positive gives me a negative. Remember that I'm looking for answers that are less than 0, so I'm looking for the negative answers. So I'm looking for these guys and these guys. That's all my negatives. Now, in terms of your actual solution, you have to be careful. Oops, I was going to change color there. So I know my solution will include these intervals, but I have to be really careful. Remember, my sign here is less than, so I shouldn't have any closed brackets. So negative infinity to 7 union 8 to infinity. The other thing that you should be looking for is, if I were to have an or equal to down here, I would still have to not include the 7 as a value. And last one for you to try on your own. Press pause, try this question, then press play to check your work. So again, this one sucks just a little bit because I got to move that 2 to the other side of my equation. So I've got 5 minus x and x minus 1. I'm moving over the 2, so plus 2, and I'm really just going to be taking it times x minus 1 over x minus 1. And then greater than or equal to to 0, because I moved the 2 over by adding 2. So that gives me 5 minus x plus 2 times the quantity of x minus 1 all over x minus 1. Distribute 5 minus x plus 2x minus 2. Combine like terms, that gives me x and plus 3 over x minus 1. So this is my new function that I'm working with. My boundaries would be where x plus 3 equals 0, because that's where the function would be equal to 0, and where x minus 1 equals 0, because that is where the function would be undefined. Then I'm going to make my table. My table would include from negative infinity to negative 3, from negative 3 to positive 1, from 1 to infinity. I would also include my factors of x plus 3 and x minus 1, and a row for my sign. Find a test point in each region, negative 5, 0, 5. Any point you want as long as it's between the two values, and start plugging them in. Negative 5 plus 3 would give me negative 2, which is a negative. Negative 5 minus 1 would also give me a negative. Negative divided by a negative is a positive. Negative 3 to 1, I chose 0. 0 plus 3, that's positive. 0 minus 1, that's negative. That sign would be negative because a positive divided by a negative is a negative. Last one, 5 plus 3 is 8, that's positive. 5 minus 1, positive. Positive divided by a positive gives me a positive. I am looking for values that are greater than or equal to 0. So I'm looking for the positives, which means I'm going to have two solutions. Before I write my final solution, oops, let me get my pen back out. Before I write my final solution, I need to take a look at boundary points. The x plus 3, it's okay to include the 3 because it's okay if the numerator is 0 because of the or equal to. The denominator can never be 0, so I cannot include the 1. So I'm going to do negative infinity to negative 3, and I'm going to include the 3, so closed bracket. Then I'm going to do union, and then the 1, because it's the denominator, can never be included. So 1 to infinity. That's my final answer.